Partial fractions. Let's say that you are given this partial fractions and they want us to decompose it. So in order to decompose this given partial fractions, the first thing you need to recognize is that it is a proper fractions. What does it mean by proper fractions? Proper fractions means that the numerator's degree is less than the denominator's degree, or it is equal to it. So in this case, the numerator's degree is less than the denominator's degree. So that means this whole expression right here is called a proper fractions. Then the next thing that you need to recognize is that the x squared plus 4 raised to the second power is a irreducible quadratic factor. What does that mean? It means that the quadratic term cannot be factorized. But if you were given on the denominator in this form, then it could be factorized into like this. But since the given is not factorized, so it's called an irreducible quadratic factor. And the other things you have to recognize is that on the denominator of x squared plus 4 raised to the second power is repeatable factor. So that means you have to write it twice. X squared plus 4, and the second thing you need to write is x squared plus 4 raised to the second power. Notice that this irreducible quadratic factor, to do the partial fractions, you need to write it like this. You need to assign a letter for the x squared, which is ax, and then plus, and you need to assign another letter for the 4, which is b. And for the other repeatable factor, you need to assign a letter for this x squared, which is cx plus 4, and assign the d for it. But if you were given in a form that is reducible, like for instance, like this case right here, x squared minus 4 raised to the second power, with this reducible form, then you just assign a letter for each of this expression, just a letter for it. And that letter is a for x minus 2 plus b for x plus 2. But the given is given in an irreducible quadratic factor. So that means you have to assign it like this. You have to assign ax plus b for this expression and cx plus d for this expression. Now that we have all this cleared up, let's get on with solving the given expression. So let's say that they give us this partial fraction and they want us to decompose it, right? So since this is repeatable, you write, because the x squared right here is repeatable, so you write it twice, the first time and the second time. And since the x squared plus 4 is a irreducible quadratic factor, you need to assign this type of letter for each of this expression. So for the x squared, you assign the ax. For the 4, you assign the b. As for this one, the x squared, you assign the cx for it, plus d for the 4. The reason why you have this ax and this cx is because this is in a form of irreducible quadratic factor. That's the only case when you put ax and the cx. Now that we have all the letters assigned for this irreducible quadratic factor, the next thing is to factor out each of this expression so that at the end you will have a linear equation. So to factor out this expression right here, this whole expression, you use the least common denominator, which is x squared plus 4 raised to the second power. And on the right hand side, you also write it like this. So you simplify it. So this one cancel with this one. So you left with 3x squared plus 4 plus 6 equals to this expression goes into this expression by 1. So you times the ax times the x squared plus 4. As for the b, you also times ax squared plus 4. As for this one, this one cancel with this one, so you left with cx plus d. Now that you have this linear equation, the next thing is to multiply out or use the distributive method. So on the left hand side, you write the same thing. As for this one, you take ax times x to the second power, which is ax to the third times 4x times 4x times a, which is 4ax. So this is a basic algebra where you just use the distributed method and times everything out. The third thing you need to do is to take the power of each variable out. So on the left hand side will be the same, and on the right hand side you take out the variable, so it will be x to the third times a. As for this one, for the bx squared, you take out the x squared. Notice that this is the highest degree, this is second degree, and this is the first degree. So you times 4a times c, because 4a times x will be 4ax, and then c times x will be cx, and you plus 4b plus d times 1. Once you have that, the other thing you need to do is equate the coefficient. So to equate the coefficient, you take the first variable, which is x to the third, you match it with the left hand side of x to the third. But since the left hand side has no x to the third degree, that means a will be 0. As for the b, x squared on the left hand side has 3x squared. So you set the bx squared equals to the 3x squared for the left hand side, and you try to solve for b. So to solve for b, you divide it by x squared on both sides. So the b will be 3. As for this one, as for the 4a plus c times x, it matches the left hand side of x. So you set them together and solve for it. So the a right here is 0 because we solve it right here. So you left with cx equals to x. To solve for the c, you divide the x on both sides. So the c will be 1. As for this one, 4b plus d equals to 6 because it's a constant. 4b plus d on the right hand side is a constant, so it matches with the left hand side of the constant, which is 6. So you solve for it. You solve for d, the d will be negative 6. Once you have that, all you need to do is plug it back into the original given equation. So the original given equation was like this. This is the ax plus 3, but since the a equals to 0, so you take 0 times x plus 3. As for the other one, we solve it earlier. The c was 1 times x plus the d, which is negative 6. So the final answer will be like this. The given expression equals to this right here.